Hi, I'm Grady Simmons with the International CCS Knowledge Center. We're an organization dedicated to sharing knowledge and information to help advance the development of carbon capture and storage projects worldwide. As part of our ongoing CCS Knowledge Spotlight series, we're exploring some of the promising carbon capture technologies that are entering the global market and discussing the opportunities and challenges that are emerging as these products look to scale up and be applied across heavy emitting industries on the journey to reaching net zero greenhouse gas emissions. Today, we're learning about the technology and services offered by Carbon Clean, a carbon capture and removal solutions provider based in London, England. They've developed a proprietary solvent for liquid amine-based CO2 capture, as well as a suite of modular capture equipment that's able to efficiently integrate with existing facilities in heavy emitting industries such as cement, steel, and energy production. We're fortunate to be joined by Carbon Clean's chair and CEO, Aniruddha Sharma, who will tell us more about Carbon Clean's vision and some of the key projects they're involved with around the world. Thanks for taking the time to chat with me today, Aniruddha.
Thanks for inviting me here, Grady.
Let's start with some of that, I guess more basic background about Carbon Clean. It's been around since 2009, which is really going back to sort of the infancy of the current wave of carbon capture and storage. Can you give me a little more history about how the company came to be and where it fits with the global CCS industry today?
Absolutely, Grady. Look, I think as a company, we've been on a journey of evolution over past 14 years. So in 2009, we started as a company focused on inventing new chemical molecules. So, to be able to replace the amine solvents, and with a view to be able to replace them, but reduce the energy cost and the corrosion caused by the amine systems. Over a period of time from there, 5, 6 years down the line, we actually moved to a system that was fully modular and could reduce the cost and the size quite significantly for carbon capture systems. And off late, we've actually found a way to compress the size of carbon capture unit by 10 times. So that's another breakthrough next generation of carbon capture. I would say as a company, we have evolved and become much more focused on industrial decarbonization. So, if you were to ask me what's the best thing you focused on, industrial decarbonization. So how do you decarbonize cement, steel, waste, refining, petrochemicals, marine applications where space is tight, budget is tight, time is limited? That's really where we are focused on.
Excellent. And you had some recent news with your company just opening a new office based in Calgary, Alberta, Canada.
Mm-hmm. Absolutely. Look, so for us, we're quite excited about Canada as an opportunity for CCS. If you think about CCS in Canada, I mean, you're there, International CCS Knowledge Center being there. I think the energy industry and the heavy industry in Canada fully understands carbon capture and storage. And they're looking for solutions where they can reduce the cost, but at the same point of time, deploy them quicker, better, faster. So this is our fourth office. We have offices in the UK, US, India, and now we are opening up in Calgary. And I'm quite excited about what we can do in Canada.
Excellent. Yes, lots of opportunities and big projects getting going here, that's for sure. Maybe let's talk a little more specifically about, I guess, the background on your technology and products. How is Carbon Clean, I guess, building on some of the existing experience that has been out there in terms of, projects like Boundary Dam in Saskatchewan, even the Quest project, some of the other large, there's a relatively small number of large projects that are operating now. And where have you seen sort of the gaps, and where does Carbon Clean fit in terms of, trying to advance the technology and bring new solutions?
Yeah. So look, we're focused on two things. One, reducing the size of the carbon capture equipment quite significantly. Like I said, we want to compress the height of these tall towers, 50, 60-meter tall towers by 10 times. And then a chemical molecule that can reduce the energy consumption very significantly in carbon capture process. So two things you're focused on. I think the experience of existing projects, which I call the first wave and maybe the second wave of projects as well, including BD3, is absolutely relevant because these projects have sort of created a milestone. You have created a supply chain. You've created a standard for the followers like Carbon Clean to actually come up and say, okay, let's just follow this standard. It actually works. People know you can supply to this standard and it works. So I think that's one important thing, that a standard has been created, supply chain has been created. I guess the second important area of the work that's already been done on existing projects or by the existing project is actually giving confidence to the regulators and policymakers. These things work. You can monitor them. You know what's happening. It's no different than running a chemical plant or a refining plant. Actually, much easier than that. So I think that's the second thing that has happened. And I think the third and probably the most important thing that has happened is the capital formation, giving the investors confidence and visibility that carbon capture plants can actually operate over a long period of time. 10 years, 15 years, 20 years is absolutely important for the sector to come up. I think for Carbon Clean, so today we operate at 49 sites globally. To date, we have delivered 2.1 million tons of carbon dioxide cumulatively captured across all those sites and locations. We operate in 12 countries today. We've worked with cement sites, CHPs, power plants, coal and gas-fired power plants, and the waste incineration sites as well. So there's such a broad set of experience that we have had, which is what we are bringing to bear as a commercial product, which we call as a Cyclone CC, where we can reduce the size by 10 times and footprint by 50%, and then work towards reducing the energy consumption in the process pretty significantly. So I think maybe one of the last things that not a lot of people have actually realized, and we are thinking about that quite actively with our customers, is the supply chain, right? The ramp up of supply chain required to deliver on the ambition for carbon capture is just huge. And we just don't see that if there is enough hardware capacity sitting in there, just excess hardware capacity. So any technology, the one like ours, which is fully modular, comes in a box, can be delivered on site in excuse me, can be delivered on a site in a couple of weeks' time, actually solves all those hurdles or problems of how do you deliver a project on time and on budget.
Right. Yeah, that's a very good point. It was something I was going to ask in terms of, some of the challenges, not necessarily just for your company, but for the industry as a whole. Certainly, there's a lot of questions being asked, over the coming decade, perhaps, around supply chain and labor, really, for what many people think will probably be a bit of a boom in construction globally. And that leads to its own challenges. Good for economic opportunities and job opportunities, but lots of challenges if you don't have the skilled labor in place. So that's really a focus for, providing a modular solution, it sounds like. Yeah.
Exactly. I think that could potentially be, you absolutely hit the nail on its head. I think the challenge with the labor and the right skill set could potentially slow down the development of carbon capture as an industry into one of the major pillars of carbon management. If you just think about existing technologies, the standard amine-based technologies today, you probably need about 4 to 8 months of construction work on site, and you need builders, you need people who know the civil works, electricians, you need the welding guys on site. If you can take all of that away and say, look, I'm going to put everything inside a box, and that box will be manufactured in a factory, all of a sudden you've solved a much bigger problem around the labor and availability of labor at the right time, at the right point.
Mm-hmm. Yeah, that's fascinating. What about, if we take a step back and look at some of the, I guess, the common challenges or issues that we've seen on some of the existing projects like BD3, I'd say, to a large extent, some of them are maybe chemistry based around, amine degradation issues, the nature of the flue gas going into the carbon capture system and contaminants and that sort of thing. How have you guys looked at that and been able to maybe address some of those more fundamental challenges from a carbon capture perspective?
Yeah, I think that's a great question, Grady. And I always say that only an experienced person who has seen these things before could actually ask those kind of questions. So it's a very prudent question. I think from our perspective and our technology's perspective, we are fully aware of the contaminants that could potentially come into the flue gas. especially in some industrial settings where the feedstock could change. The technology that we have designed is actually able to fully withstand contaminants like SOx, SOx, soot, ash, dust, chlorides, fluorides, heavy metals. And there are different treatment strategies on it. Just to name a few, one is you could either actually create a solvent that does not react with these contaminants, and or the second strategy is actually to have an active filtration system, maybe at 3 to 4 places within the carbon capture system, that keeps removing these contaminants from the system. I think the way we are approaching it is we have a chemical solvent that has mild reactivity towards these contaminants, but we do have these filtration steps involved all along the process that could take out these contaminants one by one by one. I would say we've been very blessed that we've had access to sites as early as 2012 and access to commercial sites from 2014. So we've now had the experience of running our chemical systems and processes for over a decade. And that has certainly provided us with very, very, very valuable information. I think one more thing, maybe if I could say, is in terms of the solvent, we always have to think about a philosophy of solvent management. And one of the pillars of solvent management strategy that we are thinking about is replacement. Can we replace this solvent with something better if that comes along, maybe 2 years' time, 3 years' time? I mean, just think about it as a process that you go out and buy a printer with 2 types of ink, and actually something happens, and 3 years down the line, you can actually just go and put a completely new type of ink, new color, much better, sustainable, lower cost. That is one of the things that we are working on right now, and I think that'll probably impact and potentially reduce the cost quite significantly.
Yeah. So obviously a focus on, continuous improvement, learning from experience and kind of going through iterations, as we often talk about, not starting from ground zero, but building on the lessons that are already out there from other projects, but from your own work and your own projects to improve.
Exactly. And maybe there's an element of collaboration that comes in there as well. I mean, we very actively collaborate with other project owners, developers, or test centers where there's lots and lots of information that's been generated. We share our own information, but at the same point of time, through the papers published, I think there is a community here that's providing a lot more data and information based on which we've been able to modify the technology to be able to respond to those challenges.
Yeah. And I'm interested too, maybe a little more specifically with Carbon Clean's technology and offerings with the modular approach. So it's obviously, and the packed rotating beds, that potentially presents, I guess, different issues than the traditional amine-based systems with more mechanical issues in terms of the rotating beds and that sort of thing. Have there been any particular challenges that have come up on that front from a mechanical perspective you guys have had to address?
Look, I mean, it's a rotating packed bed, and let me just unpack that a bit. So a rotating packed bed is essentially a branch of chemical engineering that deals with something called process intensification. How do you increase the speed of reaction or the speed of mass transfer by an order of magnitude? So that's really what process intensification is. In traditional systems, you have a static equipment. So you have these tall towers where the chemical is showered from the top and the gases are injected from the bottom, and they react somewhere in the middle. And the way the laws of reaction work, you need to have anywhere between 40 to 60 meter tall towers. In rotating equipments, you could actually compress this quite significantly because you can increase the reactivity using centrifugal force. So in our case, we rotate these equipments at about 9 times the acceleration of gravity, which reduces the height of the equipment by an order of magnitude into our system. So that's just the basic of process intensification. I mean, as you rightly mentioned, obviously it's a rotating equipment, so it needs more management from a maintenance point of view. But at the same point of time, it is a new equipment, which means how do you design it? How do you define the standards? How do you define the safety? Those kind of challenges, which I think are bigger unknowns in the whole process. I think from our perspective, there are some of the ways we've been trying to think about this. How do you deal with this? One of the very simple and easier way of dealing with this is a sparing philosophy. Like the way you have something for motors and pumps, you have 10 motors, you keep 2 in spare. With our technology, you can actually compress the whole equipment size quite significantly and have maybe 3 trains and just keep one of the rotating equipment in spare. So if something happens, you quickly bring it out, change, and then there you go from there. But I think just but from a technology perspective and operations of technology perspective, we haven't really seen any big significant challenges. We have obviously partnered with our customers and shareholders like Chevron. So we are demonstrating the technology with them in San Joaquin Valley in the US. We've announced a project with ADNOC in the UAE, which is starting up anytime now. So I think we have this partnership model where we go and work with the end users and ensure that they get very comfortable with the technology. They know what they're buying, and in some cases co-design with us.
Excellent. Yeah, that's fascinating. And it kind of picks up on where I was going to go with my last question, really about, the focus for Carbon Clean into the future here in terms of your sort of key projects and geographies. Where are you really focused on? What are your priorities for growing the company here in the next few years?
So I guess, we're very much focused on industrial decarbonization, so partnering with heavy industrial players. The key geographies we are focused on, North America, so US and Canada, the Middle East, and then there are a couple of other projects in Europe and in Asia as well, where we think there's going to be a huge amount of growth. I think just in terms of the focus and future growth opportunities, we want to supply a standard equipment. It's no different than buying a compressor. I think the biggest challenge with the whole carbon capture industry is non-standardization. People trying to build units of different sizes and different scales, which is obviously expensive. So we want to just standardize this across the board to say, look, here is a box that'll capture 100,000 tons for you, and this could be replicated across 700 sites in North America. So that's just a standardization we are trying to achieve for a certain industry. The second growth element is to focus on geographies and areas where there is a huge support. For example, in Canada, the Fall Economic Statement, the support from the Alberta government. I think this is a very, very strong impetus for the industry, and we want to sort of help our customers, the emitters in this case, to decarbonize their sites, but at the same point of time, achieve their goals, working with the government. I think in the end, this is all going to be about, look, we want to decarbonize by 2050, we want to achieve net zero by 2050. If you look at Morgan Stanley Composite Index, top 2,000 companies have now announced some kind of carbon reduction target. And there's just not enough hardware supply in the market available today. So we want to sort of be the company, be the player in this space that's available for industrial decarbonization, providing standard, modular, replicable carbon capture units that could potentially be produced en masse.
Yeah, excellent. I think that covers it. That kind of is a nice way to end it. Unless you have anything else you wanted to add or that we didn't cover about Carbon Clean.
Well, no, I think that's probably all from my side. Yeah, thank you again for inviting me here. And I definitely look forward to maybe collaborating more with you and your team.
Definitely. We look forward to that. Thank you very much for your time in joining us for this interview.
Perfect. Thanks.